We tend to stay pretty well ahead of our...
Welcome to the edge of nowhere.
All right. Hello, everybody, and welcome to the Monster Lore Tour Paranormal Deep Dives from the Edge of Nowhere podcast. I am your host, Jeremy Carr, here along with my co-host and the doc to my Marty, Mr. Matt O0, a.k.a. the Moz. How we doing today, Moz?
No complaints.
Good.
I mean, normally, though, the doc would work, but it's your science-y episode, so today you're kind of the doc to my Marty. Normally, if I'm doing the episode, it's one of those things.
This goes back a bit.
To the future.
Well, to the positiva negativa thing.
Oh, okay.
Because Doc, he ends up being the guy that goes, but at first, Marty's the guy that actually jumps in without knowing anything about it.
Right.
Does the experience.
So you are the Marty.
Doc's the book smart guy that actually knows how to make it work, but Marty's the guy that has to get in and go do it to see what happens.
Yeah, and he finds out a lot about his mom.
Yeah.
Okay.
It's the Rick and Morty thing all over again, really.
Mm-hmm.
And if you think about it, who are Rick and Morty, if not
Doc and Marty?
Doc and Marty.
Yeah.
The names aren't even that different.
Wow.
You know what I mean?
Blow my mind already.
The white coat, the white hair.
Yeah.
The kid. Yeah. That's
And Sherman and Mr. Peabody.
Yeah. Yeah, that's true too, except very different dynamic with the dog having the boy.
Yeah. Dog and his boy story.
The dog and his boy story.
Yeah.
All right, so we do have a little bit of old business on this one that I was good and actually took notes for the last time. I did say that I thought I had read an article about them sending information faster than light at the quantum level, which has always been the big debate as to whether that can actually happen.
Yes, currently the answer is no. And
currently the answer
is yes.
Maybe. I thought I read something that said the answer might be yes.
Yeah.
But I couldn't find it again. I found one headline that looked like it might have been right, but it was behind a paywall, so I don't think that was the one I read anyway.
Maybe you were supposed to be on the other side of the universe, and then you would have gotten the right answer.
Well, I slip timelines a lot, so I'm not sure which one I'm on at this point. But today, I'm on the timeline where that is still a no.
Okay.
At least as far as we know.
It's good. Let's go to the Old West for the third movie.
Ooh, I like that. Can we make the information travel faster than light so we can get there? That's the question.
No, you're the doc in this one.
So yeah, I might have just dreamed it, or I might have just lost it, and it wasn't maybe as much of a thing as it sounded like when I read it, because it's not really on any of the searches or anything. So take that for what it's worth. Still can't send information faster than light. But so I'm really just making, doing my self-corrections on the old business this week.
But E still equals MC Hammer. So Einstein's
Please,
still
Hammer.
right.
Don't hurt him.
Yeah.
So before we really get started, let me do the gratuitous spiel here. If you like what you hear this episode, make sure you check out our members area on patreon.com/monsterloretour. Or if you're not that deep into it, but you want to help us out a little bit, hit the like, hit the share, hit the subscribe, do all that sort of stuff. Leave us some reviews, some comments. It all helps with the algorithms in the end. Lets us know that we're actually doing a good job. So still on alien probes, but we're in our next phase here, and we're going to get into the angle of interstellar interlopers. Are you familiar with the term interstellar interlopers, Moz?
This time, a hodag ate my homework.
Hodag?
Yeah.
Aw, dag.
That's a fearsome I fearsome crittered you right in the face. Can I
That's
tell
retribution for my slide rock blaster or whatever the hell.
The slide rock. I have a
I can't
story
remember
about
its
that.
name.
Do you remember? I was
Slide rock bolter. There it is.
I was
slide rock bolter.
in the middle of this bestiary, and I've been telling you what letter I'm on because I found Teresa Bain's, and in our archives, you can basically, it says it's 1600, but basically after 1200, the rest is references. But I keep telling you what letter I was at.
Yeah.
After you mentioned the slide rock bolter in that episode, I open up the book, and the freaking slide rock bolter is staring at me. I made it to the S's.
He was on the S.
And I never would have remembered it anyway because I don't look at the fearsome critters at all, so it never would have registered. But I was like, damn you.
And that's really why I did that.
Yeah, you knew where I was.
It's because I knew where you were.
Yeah.
On the quantum level, you
yeah,
see.
You did.
Time is a spatial dimension.
Yeah.
Anywho.
It was an entangled critter.
We're talking about the wrong thing right now. Interstellar Interlopers. Thank you for letting me say it again.
I do know what it means.
Okay, what does it mean?
It's things that come from out of this, is it our solar system or our galaxy?
Our solar system.
Right. Yeah. So outside of our solar system, and they kind of...
Interstellar, between stars.
Yeah.
So pretty straightforward. The name really says it all once you break it down, Interstellar Interlopers. This is a relatively new branch of research, as the first ever known Earth contact with an interstellar interloper occurred just 9 years ago in 2014. And we didn't even realize it was there until years later. But I'm digressing. Let's start at the beginning. On January 8th, 2014, what we now know to be an interstellar interloper made contact with Earth and splashed down in the Pacific Ocean. That's right, a definite something from outside of our own solar system is laying at the bottom of the Pacific Ocean. At least it was till recently, but that's going to be the side trail. We're starting at the beginning. So what is it, you ask? Well, there's a lot of theories about that, still to this day, but first let's talk about how we know it to be an interstellar interloper.
Pacific Ocean could have been the professor who found it, and, Gilligan and Skipper might agree with him that it was, in fact...
If they remade Gilligan's Island, they should totally let Avi Loeb play the professor.
Oh, my goodness.
That would be great casting, actually. It really would. So in 2019, two Harvard University astronomers, Amir Siraj and Abraham, a.k.a. Avi Loeb, presented a paper showing that a meteor that landed in the South Pacific somewhere in the vicinity of Papua New Guinea on January 8th, 2014, was following a non-sunbound trajectory as it streaked through our solar system on its collision course with Earth. The speed and trajectory as calculated in this paper would absolutely make this object of interstellar origin an interstellar interloper, as they are known. However, this paper ran up against all kinds of peer scrutiny and disbelief from the establishment. This is because at the time this paper was presenting, Oumuamua had been established as the earliest known interstellar object. We're going to get into that in a bit. And this finding would leapfrog Amir Siraj and Avi Loeb into the history books as what is technically known as CNEOS-2014-01-08, aka IM1 for short, predated Oumuamua by about 3 years and is actually still on Earth, whereas Oumuamua is long out of reach. So of course there's backlash. The guys that already wrote the books, already wrote the articles, already think they have the science of it. All of a sudden it's, oh wait, yours wasn't first anymore, mine's first, and you know how people hate that.
Oh yeah. So the one weird one came through, swung back out. The other one is in the bottom of the Pacific Ocean, just to get everybody up to speed.
Correct. It was like an exploding fireball.
Yeah.
The one that went into the ocean.
Yep.
And the other one flew by us and was flying away before we even realized what it was and that it was even there.
Right.
But we'll get into that more as we go. But because of this backlash, this paper was not accepted by the scientific community, and the argument boiled down to insufficiently precise data for the speed and trajectory of the object as it approached Earth. It was agreed by both sides that the only ones with the satellites capable of giving precise enough data for the calculations to be fully trustworthy by the people who are all doubting it was the U.S. government. Why is the Navy in every one of my episodes?
You're a village people.
Yeah, I guess so. But specifically in this case, actually, it's the DOD that has the satellites. So ever the tenacious scientist, Avi Loeb got NASA to put in a request to the DOD for verifying data to prove the paper's hypothesis. So he went to the guys who could actually poke the DOD and go, let us see the numbers on that, and they would actually let him, you know?
It's odd that they would.
Well,
I guess they didn't deem it, you know, top secret or
right.
National security.
If it really came from there and it didn't do anything already, then it's not a national security thing.
Yeah.
It's just getting them to actually do that stuff can be rough. But if a guy from NASA calls and it's like, hey, I need to see the data on this from this, that guy's going to get his data.
Nice.
You know? So it took a few years from the time of presenting that paper. But on March 1st, 2022, which is pretty recently still, the DOD sent a reply to NASA. This letter verifies and confirms without pretense the fact that this object IM-1 was indeed on an interstellar trajectory when it made contact with Earth. There is a confirmed interloper among us, Maz.
Or two.
Is it time to panic yet?
I have a question, though.
Oh, okay.
I mean, should we send John Cusack or The Rock, or who's going to go talk to these folks about, you know, the next apocalyptic movie? If it's going to happen. We need to send the right actor to talk to these.
Talk to who?
Whoever's interstellar interloping.
Oh, whoever's sending the probes?
Yeah.
The Rock might be an impressive figure.
Yeah, actually.
He'd have to have an earpiece, have somebody telling him what to say maybe. But
his was the worst disaster movie, though. So it was that San Andreas.
Oh, yeah. I don't know. There's some bad ones, man. We should do a little bit of that later on. We could know for the side trail or something.
Yeah.
So once these findings were confirmed that this thing was an interstellar interloper, Avi Loeb, again with the tenacity, came up with the next step. Basically, his thinking was, there is a known interstellar object on the bottom of the ocean. We know within a reasonably limited area where it may be, because they actually narrowed it down to 10 square kilometers in the South Pacific, which is, when you're talking about the Pacific Ocean, that's actually not that big.
Yeah, needle in a haystack.
Yeah, like they found the needle kind of thing with that. Yeah. So he sees that, and he's like, all right, let's go get it.
No.
And he did. Or at least they found what's left of it, or some of what's left of it. That's going to actually be our side trail for this episode, is what actually came from him going out there and finding this.
It was several years ago that it crashed, though, right?
It was down there for a while, because it took him a while. It took a few years for him to even figure out if that was accurate, and it was only after they got that DOD data, which was very good, that they were able to narrow it down to a small enough area that they're like, oh, we can go find this thing. They just needed some funding, and they were on their way, kind of thing. You know what I mean? And
then they had the material for some time before they made any public announcements about it as well.
Well, actually, they just very recently, as of recording here, actually pulled it up and brought it in, and it's now it's still in the labs getting analyzed and stuff.
Gotcha.
There's reporting on it, and they have found some interesting things. I mean, you almost got to check it every day to make sure nothing new has come up.
I sent you something, actually. You got to look in your email.
Okay, I'll check it before the side trail. They have found some interesting things. I'll leave it at that. We'll get into it in the side trail. And maybe at some point in a future episode down the road, when something real comes out of it, we'll do a real update for everybody. Now, much more recently, it has been confirmed that Avi Loeb and his team have discovered yet another Earth-impacting interstellar object. This one is now known as IM-2. That first one is IM-1. And the following is an article on thedebrief.org, published on September 23rd, 2022. I'm going to have you read this for us, Moz.
In a new paper with my student Amir Siraj, we have identified a second interstellar meteor, IM2, in the CNEOS Fireball catalog of NASA. The two interstellar meteors are meteor-scale objects that collided with Earth from a trajectory that was gravitationally unbound to the Sun. In other words, the objects arrived to the solar system from interstellar space, were moving faster than the escape speed from the Sun when they were collected by the fishing net of the Earth's atmosphere. The first interstellar meteor, CNEOS 2014-0108 IM1, that Amir and I discovered in 2019, was confirmed at the 99.99% confidence level by a letter from the U.S. Space Command to NASA. The second interstellar meteor was just discovered. CNEOS 2017-0309 IM2 was 10 times more massive and roughly a meter in size. It was moving at a speed of 40 compared to 60 for IM1 kilometers per second relative to the local standard of rest, the local frame of reference of the Milky Way that averages over the motions of all the stars in the vicinity of the Sun. Remarkably, IM1 and IM2 disintegrated low in the Earth's atmosphere despite their unusually high speeds. The air-ram pressure, which is the product of the air mass density and the square of the meteor's speed when they exploded into fireballs, provides an estimate for the yield strength of their material composition. The inferred material strengths of 194 megapascals, MPa, for IM1, and 75 MPa for IM2 imply that both were tougher than iron meteorites, which have a maximum yield strength of 50 MPa. This tantalizing conclusion about the extremely rare material strength of IM1 and IM2 implies that interstellar meteors are not rocks from planetary systems like the solar system.
Let's unpack that a little bit.
So the element distribution is very odd.
Yeah, and the density tells you a lot.
Density.
So I just want to say something about the names of the things. The CNEOS 2014-0108.
It's the date.
The 2014-0108 is the date that it hit Earth, the date that it actually came into the atmosphere. So that was like day of contact for the meteor. Mm-hmm. The CNEOS is an anagram for their categorization of what they said were the Fireball catalog. Mm-hmm. I actually didn't put in my notes what it fully stands for, but it's basically the meteors that come down and explode, the Fireball meteors, the Tunguskas and whatnot. Right. That would be the CNEOS part. The other bit to unpack, so the megapascals thing. So iron meteorites, just some of the hardest things on the planet,
right,
have the maximum yield strength of 50 MPa.
This is 194.
194.
4 times Iron Man.
For the one they went after at the bottom of the ocean and pulled up little bits of, 194 MPa. Mm-hmm. So it's almost 4 times yield strength of an iron meteorite. Yeah. That's pretty impressive. And the other one's 50% bigger. The IM2 is 50% higher than that, inferably. But the IM1, that's 4 times
dense.
It's like iron. Yeah, it's like Superman's shuttle or something. You know what I mean?
Yeah, it is crazy to think of. But the other thing is, just because it was on a different trajectory, there was nothing else that wasn't violating Newton's laws in any other way or anything odd. It was just more dense and coming in from a strange section of strange angle.
Right, it came from somewhere way farther away than anything else we've known about that actually hit Earth before.
Yep.
There is a little bit more of this article, though. I'm going to read the last bit of this, if you don't mind, Moz. It is possible that IM1 and IM2 were shot out of exploding stars. This is because that pressure gauge that they had was based on how fast they were going. They were going so fast when they exploded that, it was almost an unnatural speed. They had gained so much speed in their travels. One of the theories is that they came out of an exploding star. It came out of a supernova, which would give it that kind of acceleration, you know what I mean? But it is also possible that IM1 and IM2 were moving that fast and were that tough because they were artificial in origin. Namely, chemically propelled interstellar spacecraft like our own interstellar probes, like the Voyagers.
Right.
They're going to just gain speed and gain speed.
Mm-hmm.
But these were launched a billion years ago.
Right.
You know, these are the Voyagers coming in from a different system into our system on the other side of that gap. One can also imagine a mother craft carrying CubeSats or micro devices in its belly, which, like dandelion seeds, automatically get released through friction with the atmosphere of a habitable planet.
Are you pansperming me again?
That was just from the article.
Okay.
But yes, I'm kind of panspermia.
It happens to all of us sometimes. Don't feel bad.
But we're going to get back to that concept later as well. But they are inferring, you know, the whole potential that this could be artificial in origin. So the thing to me at this point...
What about the chemically propelled interstellar spacecraft? Like, I don't remember ours being, you know... Ours was Newton driving, not...
Oh, well, there was propulsion. There was chemical propulsion in all our things to get them going. We use a lot of gravity slings and stuff.
Okay. But I was thinking in space. I was wondering, you know...
Yeah.
Leaving the atmosphere is what we're doing.
You use the propellant to get you going in the right direction, and then space takes care of the rest if you do it right.
Gotcha.
But the real thing to me at this point is the timeline of these events. I'm going to put this together with the stuff we've spoken of in my previous episodes, okay? First, we have the Tic Tac, a seeming probe-like craft taking some really quick readings, and then boom, gone. That was 2004. Then in January 2014, the first known interstellar object makes contact with Earth, lands at the bottom of the Pacific Ocean.
Lands.
I should note. So that's basically that's basically 10 years, little less than 10 years, actually, because it was 2004 and January 2014. I'm pretty sure the 2004 was like summertime, if I remember right. So you're talking...
No, it was a whole year. It had 4 seasons in it.
The Tic Tac event. The Tic Tac event, Mas.
Sorry. All right.
So we're looking somewhere around 9.5 years, right?
Mm-hmm.
Okay, so I should note that the nearest star system, Alpha Centauri, is basically 4.24 light years away. So traveling at the speed of light, which is something we've spoken of before,
would be about 10 years.
That would make actually a 9.5 year round trip.
And the orbit...
See what I did there?
Yeah, the orbit thickens.
Okay, so if there were a civilization in Alpha Centauri that had achieved this kind of travel, that they could travel basically the speed of light, then that first one sends a quick signal back, hey, there's life here, come check it out.
That's the time.
As soon as they get the signal, they go, oh, we found one.
Yeah.
And they send the next thing.
Right.
There's your round trip, which would be basically that 9.5, 10 years in between the first two happenings. Okay?
It's the most likely candidate because it's the closest. It's everything else would be extremely farther than our closest neighbor.
Right. It's just kind of weird to me how well that lines up with the train of thought I've been following in my arc here with all these episodes. Mm-hmm. I'm building a theory based on facts is what I'm trying to do.
Right.
So IM1 lands in January 2014. This is the one that Avi Loeb went after. Later that same year and into the next, the world's militaries all witness numerous and frequent radar sightings of not just unknown craft, but literal fleets of unknown crafts. Yeah. This is when the gimbal, the go fast, things like that were going on. So that's just after IM1, the first Earth contact meteor. Yeah. It's like 6 months after that. Mm-hmm. People start showing up maybe to actually take a look for themselves. I don't know. Mm-hmm. The real probe fleet shows up to really take a look. Then, in 2017, we're hit with another interstellar interloper in the form of IM2. And then also in 2017, what to our wondering eyes should appear, what was originally known as the first interstellar interloper, reduced to runner-up status, but always the first in our hearts,
Oumuamua.
technically known as I1/2017 U1, better known as Oumuamua.
Oumuamua.
So that was just after that second one actually hit Earth.
Right.
Oumuamua was flying by.
Mm-hmm.
So you see the progression there?
Yeah, it's quick. I mean,
The timeline, the way that lines up, and the progression of how the events built up.
yeah.
If you're trying to build a theory that aliens were behind this stuff, that's where you start.
Yeah.
So that's where I started.
I like it. It's a timeline.
But yeah, I feel like they were probing us. You know, a random probe was like the beacon went off. Hey, I found one.
Mm-hmm.
And then they progressively started taking more and more of a look. It's kind of what it feels like to me. Anywho, let's move on and get into the deets on Oumuamua here. This
Is CNN.
is where things really get interesting. On October 19th, 2017, astronomer Robert Weryk, that's WerYk, made an historic discovery. Using data collected by Pan-STARRS telescope at the Haleakala Observatory on the island of Maui, Hawaii, Mr. Weryk determined that an interstellar object had been observed moving through the solar system. So once again, how do they know this? It was moving too fast to be pulled into orbit by the sun. I'm going to explain this a little better for people to catch up a little bit who aren't into this. So there is a speed limit of sorts in any given solar system, any given star system, that will allow for an object to be captured in an orbit or not.
Mm-hmm.
If an object has too much velocity, if it's too big, if it's too fast, if it's a little bit of both, whatever,
That's the Hagar paradox.
it will not be captured by the sun. If it's small enough, moving slow enough, doesn't have enough mass and whatnot, it'll become a planet. At least for a while, it'll get pulled in, go into an orbit. Mm-hmm. If it's big enough, fast enough, or both, it basically just slingshots around the sun's gravity well and shoots back out the other side of the star system.
Here be whales.
And this is a long-known, established mathematical theorem. People figured out the speed limit of the solar system, so to speak, a long time ago. Mm-hmm. But it was only in 2017 that scientists first had a real-life observation of an object traveling at such a trajectory and at such a velocity to fit into those equations. So even though it was a long-established thing that, yes, anything coming from outside the solar system is going to be going faster than X, it wasn't until 2017 that they were able to actually use those equations and go, oh my God, we got one.
This is one, yeah.
You know what I mean?
Fits the bill.
So this really did cause quite a stir in the scientific community, and even caught the attention of the mainstream a little bit, to the point that network news shows covered it. People wrote scientific papers about it, and Avi Loeb eventually wrote a full-on best-selling book about it, which I read cover to cover in preparation for my Probes episodes here.
Well done, sir.
And amongst the maelstrom of attention, numerous scientists were scrambling to be the first to intuit some sort of new scientific truth about the object by dissecting what data we were available to gather about Oumuamua, the mysterious interstellar interloper, which was sadly little, but we'll get into that more as we go.
Because it was kind of on its way out before we noticed.
Yeah, the data was limited because as advanced as we think we are in this world, we aren't observant as we think when it comes to our own sky.
Right.
And we didn't even notice Oumuamua until it was past perihelion, which is the closest point to the sun. So it was already slingshotting around. It was building up its speed, you know. Yep. And on its way back out is when we caught sight of it. We didn't get any actual pictures, no up-close sensor data, only distant readings from telescopes.
I did see like a drawing of what they...
There is a picture out there that they say is a picture of Oumuamua, which makes me very angry because it is an artist's rendition based on very early returns on data that people were kind of guessing what it even looked like, what the shape was and whatnot. That picture is very misleading, and it is not Oumuamua.
Okay. I'll erase it from my memory.
Yeah,
banks.
and they really sell it to the world. Hey, this is Oumuamua, and it's like it's not at all. And it most likely doesn't even look like that. But we'll get into that a lot more too. So basically, we're just relying on our telescopes. But thankfully, our telescopes are actually pretty advanced. So we gathered enough relevant data to at least get a solid idea of the thing's basic characteristics. Okay. Nothing too, in depth about it, but we can get size, shape, speed, and, the refraction of the light can tell you a lot about what it's made up of, what it's not made up of, and how it's behaving and whatnot. So what did this data tell us? Let's look at the first scientific paper presented on the subject of Oumuamua. On December 1st, 2017, only a little over 40 days after the initial sighting, so that's really quick for a science paper, the American Astronomical Society published the Astrophysical Journal Letters, which included a paper titled, quote, Interstellar Interloper, 1I/2017 U1. We heard that. Observations from the NOT and WIN telescopes. Those are anagrams.
That's a NOT telescope.
NOT anagram and WIYN actually is the WIN.
No, I get it.
This paper was a collaborative work by a number of astrophysicists from high-ranking scientific institutions around the planet, including UCLA, MIT, Arctic University in Norway, NOAO in Tucson, Arizona, which is where we are currently recording this episode.
Are.
Yeah.
Wow.
You forget where we are sometimes because we record in so many places.
I thought we were interstellar interlopers.
We are interloping in Tucson.
Oh, okay.
Continuing, the University of Wisconsin-Madison and the Nordic Optical Telescope in Spain.
Yep.
Truly global effort here. If you're interested in the full paper, you can find it on Google Scholar by typing in Interstellar Interloper 1I/2017 U1. I will also put that in the show notes. Okay, so we are going to go through the basics of the findings presented in this paper and how these findings held up under further review and what the final findings came to be once the cosmic dust settled and Avi Loeb wrote the culminating book. But before we start, I just want to familiarize people with Avi Loeb's credentials for those who don't really know who he is, as I did the credentials behind the initial paper. So to do so, I'm going to have Maz read an excerpt from Avi Loeb's book, Extraterrestrial.
At the time of this writing, I serve as the chair of Harvard University's Department of Astronomy, founding director of the Harvard's Black Hole Initiative, director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics, chair of the Board on Physics and Astronomy of the National Academies, a member of the advisory board for the digital platform Einstein Visualized the Impossible from the Hebrew University of Jerusalem, and a member of the President's Council of Advisors on Science and Technology in Washington, D.C.
So there you go. My point is this guy's got chops, and he's one of the most respected scientific minds of our time. There were a lot of people involved in the process of figuring this all out, but the paper stood as first word, and Avi Loeb's book pretty much stands as the last word on what we know about Oumuamua. So let's see what they all had to say about it, okay?
Oh, wait, my resume has some gaps, but it's otherwise similarly as impressive, I find. Chair of the, yeah.
I could make one up to sound that good.
I know what some of those words are.
Yeah, I know. I don't even know what half of the stuff he's even trying to do is with a resume like that. But anywho, into the findings here. The initial findings on the average radius of the object was approximately 55 meters. Extrapolating from that, we get an average width on the wide side of approximately 360 feet. Okay, so that's the length of a football field with the end zones, basically, to put it in perspective.
Right.
Okay. And this data held up. You will typically hear scientists refer to Oumuamua as approximately the width of a football field. So good job there.
Mm-hmm.
They nailed that right off the bat. The paper also found there was no notable tail, like you would see on a typical comet.
Right.
Their calculations show that no more than a few square centimeters of the surface could be ice or any sort of material that would exhaust under the heat from the sun for this to be the case.
Mm-hmm.
Upon further review of the data by other groups of scientists, it became clear that Oumuamua was definitely not a comet. Let's hear from Avi Loeb on this point.
And when astronomers tried to look for any cometary tail around it, they couldn't see any. And so it was clearly not a comet. The Spitzer Space Telescope looked very deeply for any gas around it, couldn't find any carbon-based molecules. So it was clearly not a comet of the type that we have seen before in the solar system.
Okay, so there you go. No tail, not a comet, by definition. By current definition, not a comet. Some scientists went on to argue that if Oumuamua were a solid block of pure frozen nitrogen with no other elements present,
then it would make a tail.
Then it could have been exhausting pure nitrogen and creating a tail we couldn't see, because nitrogen is a very difficult element to see.
So they went through
even with all our telescopes.
They went through this whole brain game just to come up with something we can't see anyway.
Right. This makes sense theoretically, but there is a serious problem with this hypothesis, and I'm going to have Avi Loeb explain that problem to us.
And the problem with that is nitrogen is produced together with carbon in the interiors of stars. You never get just pure nitrogen. You get a mix of nitrogen and carbon in almost every object that we see. And carbon could not have existed, could not have evaporated from Oumuamua based on the observations by the Spitzer Space Telescope. There are very tight limits on all carbon-based molecules, and you couldn't have evaporation of nitrogen without carbon.
Right.
So there you go. There's plenty of nitrogen out there for something like that.
It's not pure.
But it's never going to present itself as a huge chunk of pure nitrogen. That's not a if you see that, somebody made it.
Right.
Is basically, so either way, it's not natural.
Yeah, I get it.
So not very likely. Another factor with this theory is that if Oumuamua were in fact a chunk of pure frozen nitrogen, then even though we wouldn't perceive its tail, we would perceive the loss of mass it would undergo as it made its way around the sun.
Right. That's burning away.
Right, because it's it's like emptying your gas tank. It is calculated that in order for Oumuamua's acceleration to be accounted for by cometary exhaust, it would have lost at least 10% of its total mass on its way through the solar system. However, in all of the data we collected from the object, we perceived no notable loss of mass. Now, we did find it late, so we would have missed a lot of it. We would have missed a lot of it, but it still would have been losing mass, and we saw none of that. In fact, as noted in Avi Loeb's book, NASA scientists using super advanced astronomy equipment I can't even pretend to understand, calculated that Oumuamua had a water production rate that was smaller than any of the previously reported limits by at least an order of magnitude. These same NASA guys also found that Oumuamua must be shinier than a typical comet or asteroid. That is the only way it could have reflected as much sunlight as it did, while still being small enough to not produce much heat.
So a ship, like what you would expect a ship to the outside of a hull.
Sounds like it, doesn't it?
Yeah.
You're a smart guy, man. This has major implications that Oumuamua wasn't just weird, it was literally unnatural. Mm-hmm. There are implications here. So, as far as comet theory on Oumuamua goes, we're on strike 2, okay? It's not looking good for it to be a natural comet. Now, if we want to be scientific about it, we have to ask what past data says about the situation. And here's Avi Loeb on that point.
The other thing is, we've never seen a nitrogen iceberg. And, we've looked at numerous, there are about, a billion objects bigger than the size of Manhattan Island in the so-called Oort cloud of the solar system. And all the objects we have seen from there appear to be rocks, the kind of objects that we expect, that are the building blocks of the planets that we see. Right. None of them was pure nitrogen. Yeah. So to argue that the first object, which should be, by the way, the most common, was made of nitrogen, to me is very strange, because it's a rare, it's a rare oddity. It's just something that we've never seen before. And why would the first object look like nothing we've seen before in the solar system if all stars resemble the solar system?
So there you go. All the evidence against it being a naturally occurring thing, as far as we know about, with all we know about space and everything.
Or at least comets. We're ruling out comets.
Yeah, so strike 3, it is definitely out of the comet category. That brings us to the asteroid theory. Okay.
Put in another 25 cents.
Everything we know of that's flying around out there is either a comet or an asteroid.
Right.
So if it's not a comet, it has to be an asteroid, right?
Or a Musk.
Yeah, there's a Tesla out there somewhere.
Yeah, a happy fun ball.
God damn. Tesla's happy fun ball. Yes. Different Tesla. So let's get into the asteroid argument then. We deleted comet off the list. Let's see if it's an asteroid, because they do behave differently. The initial paper found that the mantle or outer crust of the object, if it were some sort of asteroid, would have to be at least 0.5 meter thick in order to keep any reactive substances within it from venting and creating a tail, cometary tail.
A hull. Back to hull.
There you go. You're so ahead of me, but I love it, honestly. This would be an atypically thick outer surface, but many scientists theorize that the trip through interstellar space would have exposed the object to all kinds of intense radiation that would have worked to harden the outer surface. Again, this is a very plausible hypothesis, but the asteroid theory doesn't really hold up to existing data on asteroids either. The main problem with the asteroid theory is Oumuamua's odd shape, actually.
Cylindrical.
It's
pointy, cylindrically.
Actually
coney.
Comes out...
It's like a cone.
Well, we'll get to it, because we're going to go through it.
It's like the Doomsday Machine from that Star Trek episode.
Let's hope not.
Yeah.
The initial paper calculated the axis ratio, the difference between width and thickness of Oumuamua, to be 6-to-1. Be 6 times wider than thick.
But is one side bigger than the other? Was it more cone or was it more cylindrical?
Well, it's roundish.
Yeah. So it's more like like you said. You said it was a disc. It could be a disc.
It's coming out more like a pancake.
Yeah.
Than a cigar, because what you see a lot is the cigar shaped. That's that picture we were talking about that isn't actually a picture. But we're going to get into that. You're getting way ahead of me.
The pancake episode was Operation Annihilate. That was a much later episode.
Now I need pancakes. Damn it. Anywho, let's get back on track here. So the initial paper calculation axis ratio was 6-to-1, 6 times wider than thick. It is a very odd finding, as the most elongated natural bodies we have discovered in space otherwise have an axis ratio of about 3-to-1. And those are the outliers.
Mm-hmm.
Those are the ones that we look at and go, that's shaped funny. And that's 3-to-1 compared to 6-to-1.
And how far you have to go for syrup in this galaxy.
Stop talking about pancakes. You're going to make me hungry in the middle of an episode that never ends well. Anywho, most asteroids, as Avi Loeb said in his remark about the Oort cloud, are essentially round. In fact, all of the natural bodies we perceive in the solar system are at least generally somewhat round.
Yeah, ratio-wise.
And look at every picture ever taken of any heavenly body, you know what I mean? You're going to see round, unless you're on a page for flat Earth. This is not that page. This 6-to-1 ratio is a very odd finding indeed, but it was soon to get downright weird. When more groups did their research into the data on Oumuamua, the consensus became not a 6-to-1 ratio, but a 10-to-1 ratio. 10-to-1 is so far out of bounds with the general makeup of the universe and just how things work.
It's like that Aerosmith song.
There is no denying that there is something very odd about this particular interstellar interloper. Which Aerosmith song?
Big 10-inch, sorry.
Ooh, I love
Record
that
of
song.
the band that plays the blues.
Band that plays the blues. We won't finish that. This is kind of a family program. All right, but let's get back on it with some more on the asteroid theory from Avi Loeb.
But people said, well, maybe it's an asteroid, just a bare rock that doesn't have any evaporation off its surface. The problem was that as more data came in, it became clear that the object has an extreme shape because the amount of sunlight that it reflected was changing by a factor of 10. And that implied that it's 10 times longer than it is wide projected on the sky as it was tumbling. And moreover, the best fit to the data was that of a flat object, a pancake shape, not cigar shape. Sort of like a piece of paper tumbling in the wind.
So there you go. Pretty well not an asteroid, giving us that pancake shape, not the cigar like you see in the so-called picture.
So pretty much Bob Dylan was right.
So, but with that picture, so early on in the information flow that came out about Oumuamua's discovery, it was believed to be elongated, but still sort of round and almost cigar-ish, which is where that picture came from. Because they wanted to get on it quick. The press wanted the story now. So they gave them what they had based on what they had found. Turns out, because science likes to check itself and change its mind when it finds new data that proves them wrong, we now know that that picture is actually quite inaccurate. And in fact, I have a quote here, an astrophysicist at McMaster University evaluated all the brightness models the data allowed and concluded the likelihood of Oumuamua being cigar-shaped was small, and the likelihood of Oumuamua being disc-shaped was about 91%.
Nice.
So there you go. It's very, they can't say anything for absolute certain because we didn't get a good enough look at it.
Yeah.
But we have good enough data that they're over 90% sure it was flattish, roundish, disky.
So Freud was wrong again.
Well, yeah, but you know who was right? Is everybody who's ever seen a flying saucer type UFO.
Yeah.
But this isn't the only strange thing. Just as strange as its elongated shape was the way Oumuamua was moving. It was moving wrong. Sorry, was that too technical?
No, it's awesome. It's intriguing.
Yeah, the original paper found, to put it in layman's terms, that Oumuamua's speed and acceleration were unaccounted for by the gravitational effects it would have encountered on its way through the solar system. It was going too fast and accelerating at too fast a rate for it to be the actions of gravity alone.
So Newton isn't driving anymore. Yeah.
Right. They do not state this part out loud in the paper, but since we know it wasn't venting anywhere near enough cometary gas to account for the propulsion either, this indicates some sort of onboard propulsion.
Which brings me to my space fart theory.
But this is still not the... Did you say space fart?
I'm sorry.
Space
That's different.
fart.
That's for a different episode.
In space, no one can hear you fart.
If,
Yikes.
the sound of one cheek fart is a cone. It's a Japanese cone.
But anywho, this is not the whole story. Let's let somebody serious talk for a minute. We're going to let the adult talk again, Maz.
Wow.
We're going to hear from Avi Loeb on Oumuamua's odd motion.
And moreover, after that, the object showed a deviation from an orbit that is shaped just by the sun's gravity. And the question was, what is pushing it away from the sun in such a smooth way, a force that declines inversely with distance squared from the sun? And the only sense I could make of that fact is that it must be pushed by reflecting sunlight. It's sort of like a sail, a very thin object that is pushed away from the sun by the reflection of sunlight. We've seen such an object actually again in September 2020 with the same telescope. It was given the name 2020 SO.
They found an unidentified object in space just 3 years after Oumuamua's flyby. Another oddly elongated, seemingly unnatural object being propelled away from the sun in a similar fashion to Oumuamua with its unaccountable acceleration. This is the object 2020 SO that he's talking about. This was exciting. We were like, oh my God, there's another. We might actually figure out a new law of nature or something. We saw something weird and it was acting unnatural, right? We're looking for a correlation with something else that shows it is natural, and it's just following some new
And
rule we
it's
don't know.
not.
But we found it. That's what I'm getting at here, Maz. We found another one. This is something most people haven't heard about. Very exciting to be able to compare these oddities in nature. Let's hear what Avi Loeb has to say about it.
And then astronomers realized that it came from the Earth. It's actually a rocket booster that was launched into space in 1966 as part of a mission to the moon. And we know that this object is thin because we produced it. And indeed, it showed a deviation as a result of reflecting sunlight and didn't show any cometary tail. So it shared the qualities of Oumuamua. We know we produced it. The question is, who produced Oumuamua? Nature doesn't make sails.
Oops. It was our own space junk. Nature doesn't make sails, Maz.
But that's the only thing it resembled was what we've done.
Right. The only other space-bound body we have ever witnessed that behaved like a Oumuamua was a big piece of our own space junk that was floating around up there. So only 2 objects with the similar data set, and we made one of them.
That's the only signature of something we've done.
Right.
Is what
The only thing we can find that behaves like it is stuff we have made.
But-
So who made a Oumuamua? That's the question here, Maz.
Right. It was another intelligence somewhere elsewhere.
That is the concept.
But the sail part of it, I know there was maybe I didn't grasp it, but the sail was that it was like I've seen where you catch the solar.
We have conception
Right.
of the idea. They're building them.
Yeah.
I don't think they've really used it yet, but we know it works, kind of thing. You know what I mean? And they're getting ready. We're going to get into it when we get into breakthrough starshot and all those things later on in this series. We're totally going to get into solar sails more. But
Did you just starshot me?
I can't even say it. Yes, I did. But anywho, so the cards are really stacking up against a natural origin of Oumuamua. But good scientists are always open to the presentation of new data, willing to reinterpret their own findings to keep up with the new information, right?
Yep.
Here's Avi Loeb. Here's where Avi Loeb stands on that point.
Well, in science, we are never absolutely sure of an interpretation. We just put all the possible interpretations on the table, look at the evidence, and ask at any given time what's the most likely interpretation. And at the moment, I should say that all the natural origin interpretations look less likely to me compared to the artificial origin.
So there you go. That basically brings us up to date on the whole Oumuamua debate, based on what data we were able to collect about it. You know, as an aside, I feel like we should give Oumuamua a theme song.
Wow.
Yeah, Intruder by Peter Gabriel. Are you familiar with that one?
Oh, it's weird that
Because it snuck by us and it was leaving before we even knew it was there, and it was so dark we couldn't really see it. It's just like kind of this shadowy thing.
Yeah.
It's a really creepy song. If you don't know it, you can pause us and look it up on YouTube or something. Intruder by Peter Gabriel.
Nice. Consider my monkey shocked.
Yeah, there you go.
It's my only Peter.
That song will definitely shock your monkey.
Yeah.
Yes. Anywho, so we're up to date on the Oumuamua debate. You will see another batch of stories come through a news cycle once in a while on this stuff, but there rarely seems to be anything new on it because there was only so much data collected. The headlines about aliens get good attention, make good clickbait essentially, so the press likes throwing it out there every few months or so you can catch up on these stories every once in a while. The last round I saw, there was a headline that said they had finally figured out what Oumuamua was. So I click on it, and it was an old argument about it being a solid nitrogen comet, which we already discussed in this here podcast, and let you know that Avi Loeb and his fellow scientists pretty much, ruled out the possibility of such a thing because it's just so unlikely. It's actually more likely that aliens built it than it was solid, pure nitrogen. You know what I mean? However, there is one new element that has been added to the legend of Oumuamua. This coming from the man himself, Dr. Avi Loeb. He has publicly considered the possibility that Oumuamua was not only some sort of alien-built technology, but that it could be a full-on mothership stalking our system from the shadow of the sun.
It's totally what anyone
was
would
that
think.
Ominous enough for you, Maz?
I don't think that's I think where most people would go with that.
Yeah, really though,
What
right?
else are they doing?
But here's an article from space.com written by Hannah Osborne, published on March 25th, 2023. You want to read this for us, Maz?
Sure. Alien mothership lurking in our solar system could be watching us with tiny probes, Pentagon official suggests. A draft paper by Harvard scientists and the head of the Pentagon's UFO office has raised the idea an alien mothership could be in the solar system sending out tiny probes dubbed dandelion seeds to explore the planets within.
We mentioned that dandelion thing earlier in a previous reading.
Yeah. Could an alien mothership be hovering around the solar system sending out tiny probes to explore planets? According to a Harvard scientist and a Pentagon official, it's possible. In a draft paper, the pair said it is feasible an extraterrestrial spaceship could be in our galactic neighborhood, exploring the region by means of the dandelion seeds, small spacecraft that can gather and send back information similar to the way humans send out spacecraft to explore planets. Avi Loeb, an astronomer at Harvard University, and Sean M. Kirkpatrick, director of the Pentagon's All-Domain Anomaly Resolution Office, AARO, established in July 2022 by the Department of Defense to detect and study objects of interest, released the draft Physical Constraints on Unidentified Aerial Phenomenon on March 7th. It is not an official Pentagon document, but was carried out in partnership with the DoD. It has not been peer-reviewed. You know, either is our work. I think we should point
Thank
that out
God.
now.
We would never pass that bar.
6 months before Oumuamua's close approach to Earth, a small interstellar meteor measuring around 3 feet 1 meter wide smashed into Earth. This meteor, IM2, was not related to Oumuamua, but it got Loeb thinking. That coincidence inspired him to consider the possibility that an artificial interstellar object could potentially be a parent craft that releases many small probes during its close passage to Earth, an operational construct not too dissimilar from NASA's missions. These dandelion seeds could be separated from the parent craft by the tidal gravitational forces of the Sun or by a maneuvering capability. In the draft paper, Loeb and Kirkpatrick looked at UAPs confined by known physics. The authors suggest the dandelion seeds probes could reach Earth for exploration without being detected by astronomers, as they would likely be too small to reflect enough sunlight for survey telescopes to detect. Equipped with large surface-to-mass ratio of a parachute, technological dandelion seeds could slow down in the Earth's atmosphere to avoid burnup and then pursue their objectives wherever they land, they wrote. Aliens would likely want to explore rocky planets with an atmosphere in the solar system, the authors propose. From a distance, Venus, Earth, and Mars would all look appealing, with Earth being of greatest interest once aliens found signatures of liquid water. The alien civilization that created the probes would not need to be on the mothership. It would be unlikely that it could even communicate with the probes.
So we're leaning real heavy to the weird side here, Maz. Oumuamua could be the alien mothership our mothers all warned us about when we were kids, you know?
Mm-hmm.
If this does turn out to be the case, there is really only one question left to worry about. Is it going to be Star Trek or is it going to be Battlestar? You know? And this whole dandelion seed thing gets me thinking about all those little craft. You know, the videos we were watching in part 1 and the IM-1, the IM-2 meteors that are falling to Earth and showing signs of being artificial themselves with their densities and, you know, their tensile densities and whatnot. The Betz sphere that we talked about. All these things we're talking about. Like, what if the Betz sphere fell in a parachute through our atmosphere and upon landing started a small brush fire due to its heat from the atmospheric entry, and now it's been observing us ever since?
Yeah.
You know, it's a dandelion seed. The Betz sphere could be. Is it a dandelion seed?
Yeah, that's what you're saying.
Yeah. What if those IM meteors we discovered did the same thing and are working on some vast alien conspiracy to take over our world through stealth? I kind of want to panic now, Moss.
You're going Battlestar.
I'm going Battlestar, baby.
Yeah.
It's like Mad Max and Battlestar all at the same time. That's what I'm going for.
Well, most of the Star Trek episodes weren't that great either. I mean, that's still a mixed bag.
Well, it was a nice existence, though. It was very
Yeah.
There was no war. Everybody was working together. It was very, communal.
Yeah. You get Romulan ale sometimes.
Yeah,
Some
Romulan
little
ale
neutral
sometimes.
zone. Yeah.
Green aliens and stuff.
Yeah. Yeah. Wrigley's Pleasure Planet. That's a very obscure reference, but you Star Trek fans, you know for sure.
My mom will like that one, so thank you. But there is still one hope in our saga for finding naturalness in Oumuamua. I'm not done yet. I'm trying to debunk this whole unnatural thing about Oumuamua. I'm trying, Moz. It had the luck to be the first ever observed interstellar interloper. So it actually did have the luxury of no direct peers to compare it to. We didn't actually see the ones that hit Earth. They came down, they exploded, and then we went, oh, they came from farther away than we thought. So we don't know what they looked like. We did find something that we made that kind of resembled it in its movement and whatnot. But we hadn't actually seen, had data on the physical buildup of another interstellar interloper. So we are missing a data set here to really know, okay? So now to recap just a little bit, we know what the stuff in our solar system is made of. It's all pretty similar stuff. Takes pretty similar forms and structures. Everything's kind of roundish,
Glitter, rainbows, and bunnies.
There you go. We have also been observing other systems for a good while now with advanced telescopes of many kinds, and all the data suggests that all we can see out there is pretty similar to the stuff we see here. Mm-hmm. It's all very similar. But to be truly scientific, you must allow for unknown variables. And the fact that we had no other proven interstellar objects seen within our own star system gave the last bit of pause to the unnatural origins crowd. Mm-hmm. Not quite proven it yet. If the next interstellar interloper we encountered matched the weirdness of Oumuamua, then we could establish that there are a number of interstellar objects that we consider weird that are actually quite natural and just come from a place with a galactic environment that we're not familiar with.
But I'm sorry to do this. Mm-hmm. What if something was blown out of a neutron star or a pulsar or something?
That is another argument. I forget if I really get into that one, but there's an argument that it's a chunk of a planet or something that underwent a catastrophe. That
eventually gets smaller and smaller, but still moving very fast.
Yeah, like a planet shattering type of celestial impact.
Yeah,
that is a concept too, but it still doesn't. It's still not solid nitrogen. It's not doing this. It's not doing that.
Right. It should lose mass as it goes through.
Yeah, like it should still be behaving differently than it did. If that were the case. So we're looking for
love.
One more piece of data. With one more piece of verified matching data, Oumuamua could actually be let off the hook as an unnatural interloper.
Of things that do happen.
If we found something else that came in the same way and behaved and looked and whatnot the same way, then we'd be like, oh, okay, the rest of the universe is weirder than we think. But like Avi Loeb said, the first one you see statistically is should be what is normal,
right?
And this one did not seem normal.
Mm-hmm. But we get full data from a full swing through, and we say, "Oh,
we need something to direct something actually coming from a similar place, going to a similar place that looks and behaves similarly." That would be its saving grace, and we could go, "Oh, it is natural." And I have great news, Maz.
We found one.
Wouldn't you know it, but not even 2 years after the passing of Oumuamua, we discovered another interstellar interloper in our star system before it went crashing into anything, before it got away, and we couldn't get a look at it. After going so long, having never laid eyes or a telescope or anything else on an interstellar object that we knew of within our own region of space, we find two in less than 2 years.
Dang.
maybe credit the telescopes. Maybe there's something a little weird going on. But this new interloper came bearing huge implications, not only for the classification of Oumuamua's strangeness, but for our star system as a whole.
A black hole.
And we're going to get into that in part 3 a little farther on down the road, because this is the end of part 2. I always want to leave them wanting more with these multi-parters, Moz.
There you go.
But we do have to wrap some things up before we go. First off, I do want to present this week's Mad Cujo's Award. I think everyone can predict this, that Dr. Avi Loeb is this week's winner.
Shock of shocks.
For being a true scientific badass who isn't afraid to buck the norms of scientific inquiry and ask some proper questions, in my mind. So well done, Dr. Loeb. Well done. Here's your Mad Cujo's Award.
Down, boy!
And now, since this is part 2... we're going to do a cliffhanger version of our closing segments. So let's get into this week's Oumuamua Theory of the Week. Oh no, here it comes!
Quick, to the batshit signal.
Moz kind of let me off the hook on this one. He said he was going to do the Oumuamua for me, since I got to do multiples for this whole probe series.
Nice.
So, and I have no idea what you're going to say, Moz.
Very nice of me.
I'm a little scared.
No, it just gets a little dumber because...
well, it's an Oumuamua theory. It's batshit. So
I was always intrigued with the Betz sphere, even when I saw that video back in the day. It did strike a chord with me. And when you brought it back up and we talked about it, I'm thinking... I came up with my own Oumuamua file a little bit with the whole Tesla thing.
okay. Oh, you're going to go back to the Betz sphere for the Oumuamua?
It's a probe. This is still the probe episode. I just want to take it one step further.
It still fits. Yeah, totally. For the parts 1 and 2, we're going to do a big one at the end when it's all done. So we can just hit the pieces for now.
Yeah. Well, I think in 1908 you have the Tunguska blast. Now there was a theory, a kind of a little side theory that Tesla actually, it was a death ray he was working on.
Oh, really? They were trying to say Nikola Tesla actually had something to do with that?
Nikola Tesla had to look at his data, and he was doing his experiments, and he's trying to do a global electrical
he
force.
wanted to give everybody energy kind of thing.
Right.
Yeah.
So he actually was like looking at his papers like, did I do that? Like,
oh, no, I didn't even know that.
Now, by the way, the Tunguska blast was 12 megaton explosion that they believe burst in the atmosphere on the morning of June 30th, 1908. 80 million trees were knocked down, and it was an area of 2,150 kilometers were kind of decimated.
That's
830 square miles of forest.
Wow, 830 square miles. Did you say 80 million trees?
80 million trees.
Wow.
You ever see the footage from that? It's just
I've seen the pictures of
hills and hills
the giant
and hills
butterfly.
of just down trees.
And it has kind of a pattern to it. Like you can see where the center was even. It's wild.
It's a wild kind of thing. Now, it's basically the area between Chicago and New York, and only 3 people are reportedly dead from this.
Well, because it was Siberia in 1908.
Yeah.
Yeah.
So they don't even know that. They just guess. It's like, I'm sure it got like 3 guys. Let's just say 3 guys.
And there could have been a whole village of indigenous people out there that were right under the thing.
Yeah,
Sasquatch. They just didn't even count
How
them.
many Sasquatch did we lose in that event?
That's a great question, too.
And we may never know. But I'm thinking, this is my Oumuamua theory for today.
Okay.
He sent out the proto Happy Fun Ball. And it didn't work. And when it came back, because he sent it out, an Interstellar Interloper, when it came back really fast, wrong angle, boom, when it hits the atmosphere.
Wow.
Yeah, not so happy fun ball. They said, SNL tells us.
So a Betz sphere, a similar thing to the Betz sphere, which was Tesla's Happy Fun Ball.
Yes.
His prototype Happy Fun Ball.
Correct.
Exploded over Tunguska.
Yes.
In 1908.
Yes.
His later built, updated Happy Fun Ball was discovered in Florida by the Betz family.
That one came back, and the Betzes found it 30 or 35 years later.
Maybe it started going so fast it went through some kind of time portal.
Yeah.
And when it came out, that's where it landed.
Yeah, but the prototype
That's some good ahulguanoing there, Maz.
was a disaster.
That's Tesla did it.
Tesla did it.
Hey, what happened in Tunguska? I don't know. Tesla did it.
Here's the thing. SNL tells us, don't taunt Happy Fun Ball. Maybe somebody in another galaxy taunted Happy Fun Ball. They taunted
the Happy Fun Ball.
And when it came back, it was really mad. It was just taking it out on whatever planetary body it hit. We don't know.
We don't know.
We don't know.
I love this theory. I'm going to write a book about Tesla's Happy Fun Ball.
I pretty much bailed you out for your mouth.
I appreciate that. That was way baddier than anything I would have come up with for that right there, so I appreciate that. I was just going to say reptilians again.
Just reptilians.
When I don't know what to do with an ahuguano, I just say reptilians.
Yeah. When he's scared, he says it too.
When in doubt, blame the reptilians.
Don't spook Jeremy. He'll just say reptilians.
All right, let's get back on
screaming away.
Let's get back on a little bit of a factual setting here and do our Sir Richard Scully Muggles Skeptics Review.
You're full of crap, and that's the nicest thing that I can say.
Okay, so there's levels to this. We've covered some stuff in these first couple episodes. The Betz sphere is at the end of the legacy there when they don't get the real one back the second time. That was the skeptics opening to just be like, oh, it was never a thing to begin with.
Yeah.
And that's totally it. That's the end of the argument. We don't care about your videos and your pictures and your witnesses and everything else. Yeah. It doesn't do anything now, so it never did.
Right.
There's your bets, skeptics. Oumuamua, we kind of covered that.
Yeah.
Already, that, you know, they were trying to find all these different ways to say, oh, no, it's a natural thing. It's a natural thing. But all their arguments, like if you put it under real, you know, objective scrutiny, they just don't hold up. It actually adds up to it being more likely to not be natural.
It's not much for the Scully Muggles to say at the moment until we find those other patterns, those other things coming into and we get more data on these interlopers.
And we're going to meet the next interloper in the next episode. At the beginning of the next episode, this carries on. So I don't want to go too deep into the skeptics thing yet anyway. So we'll save that for the next round, and we'll do our own believability scale, our Skulder-Mully believability scale.
They feel your methods, your theories are
spooky. Do you think I'm spooky?
Wait, why am I Scully?
Thinking we'll do the Betz sphere and Oumuamua here real quick. Okay. What we think of them. We kind of unofficially did the Betz sphere in part one. We kind of talked about how we felt about it.
Yeah.
I'm like an 8.5. That thing's a full-on alien probe.
Oumuamua.
No, Betz sphere. We're doing the Betz sphere first.
Betz sphere first.
Yeah.
Okay.
The Betz mystery sphere, as it's officially titled most of the time. But it was so proby. You know what I mean? Like, it moved itself around, it reacted to energies, it built up energies, and it protected itself from falling off the table and stuff.
Yeah.
You know what I mean?
Rolled back up the table.
Yeah, exactly. Yeah. Like, they push it, and it wouldn't roll off the table.
Yeah.
You know?
And Tesla's doing that in his grave right now, like rolling up the coffin because he's angry.
The only reason I don't actually give it higher than an 8.5 is because I'm not completely sure on the probe part. Mm-hmm. I'm pretty sure it was full on technology that humans didn't make. Mm-hmm. That part I'm basically a 10. Whether it was actually a probe gathering, collecting, sending data specifically, not I can't be wholly sure on that, obviously. Like and even with, you know, letting myself go and whatever I want to think, I can't be full on that. So I'm going to give it an 8.5. I think this is my first ever 0.5.
I'm just going to, and I didn't do this ahead of time, but this is the first time we're going to agree because you can never be 100% sure. However, I don't understand why a journalist came there, vetted it, and was convinced something was, this couldn't be happening. It's the 70s. What is this ball doing? And they didn't benefit from this. So many people tried to steal it, and eventually
which ultimately they did. Yeah,
I just don't know what it is. It is a mystery. It's a mystery sphere kind of thing.
It's well named.
It's
Except Tesla's Happy Fun Ball is a better name than Betz Mystery Sphere.
That's what we do. We renamed the Gloucester Sea Serpent.
Slinky the Sea Serpent.
We've solved
Episode
two Batman.
2.
The original Batman was, we all believe now.
Dude, like, I'm not even kidding. I'm pretty sure we found the inspiration of the Batman character.
Yeah,
I'm pretty sure we did. Even if he wasn't living like Batman, I'm pretty sure, if you haven't listened to it, spoiler alert for episode 12 right now, or 13, one of the Stanley Hotel saga. Pretty sure F.O. Stanley was the guy that inspired Batman.
Yeah.
Because one of the creators was living in Denver. Like, he was 26 when F.O. Stanley died. Like, he knew this legend of this guy. And with all the pieces put together, how is that guy not an inspiration for Batman?
I'm a little disappointed we've only solved several mega mysteries in the first 14 episodes.
Right.
But,
Slackers.
there's more to come.
All right.
And some of it's almost plausible.
Some of it's almost good.
Yeah, I think it's good. I would go to good. We have some theories that I don't understand what we've done.
Like, we really blow my mind. It's crazy. Like,
we all blow his mind.
I thought this was my process, but then we do episodes and it blows my mind. So hopefully we're doing something right and we're not just two crazy guys talking into a microphone at each other.
Well, yeah.
I guess either way we're that, but hopefully other people like it, I guess is what I'm going for. And anywho, let's wrap this thing up with our final segment, Wolfman Puck's Cryptid Culinary Corner.
Oh, boy.
Your entree, sir. Smells good.
I think I got something for this.
Okay, so this is a long road, this probe series I'm doing. So we're going to need a good hearty meal here at kind of the halfway point. So what we're going to be serving tonight in honor of our Interstellar Interloper theme for this episode, the one, the only, the classic, the legendary, the Blob.
Wow. Downingtown, Pennsylvania. That's where the diner is.
Because I'm pretty sure that guy came from out of this solar system, man.
Nice.
The Blob is like the original Interstellar Interloper, if you want to add pop culture and movies and whatnot into the argument.
Beware of the blob. It creeps, it crawls, it moves around.
I didn't even write anything for this. Do you want to go first? Do you want me to go first?
I started this while you said we had to do this, and I'm ready.
All right. You go first and see if I can.
Now here, I have to have blob as like a basket ingredient.
The blob has to be the main ingredient of the meal is the blob.
Okay.
Or at least pieces
I have
of.
now just changed what I'm doing, and I'm still going to win.
There you go. Let's do it.
So I am making Rocky Mountain Betz spheres, but in
oh my God,
a jelly,
I don't even want to know what that means.
Like Rocky Mountain oysters.
Yeah, but who are you cutting the Betz spheres off of?
Well, like Dr. Manhattan from The Watchmen. Let's just say that. So they're blue.
Yikes! This is the side dish.
No, this is the main dish because I'm going to serve
use
it.
The blob.
I'm serving it. You're not even.
I'm sorry. Go ahead. I'm interrupting.
You are serving this, of course, in kind of a jelly blob kind of dipping sauce. Jelly blob dipping sauce.
Oh, gross! You're gonna dip
Dr. Manhattan's.
Okay, Dr. Manhattan's
Rocky Mountain oyster spheres.
Oyster spheres. My goodness! And you're gonna dip them in the blob.
You're gonna dip them in the blob. You have to have a sauce.
Dr.
It's
Manhattan's.
like poppers. Everybody likes jalapeno poppers.
I need to get this name. Dr. Manhattan's Rocky Mountain Betz spheres.
Yes. Thank you. Thank you for bringing it home. And I'm serving it with a Breckenridge Brewing Company Oktoberfest because they're probably on sale now, and there's probably the last few batches. You know, I'm always about getting a discount when it comes to brews. Yeah.
I have.
Yeah.
You know when the other team scores 10 runs in the first inning and you're like, the game's already over?
That didn't happen tonight.
Here's what I'm going to do. I am going to feed Maz to the blob and steal his trophy for winning this Wolfman Pucks right here, because there's no way I can't even try to compete with that I'm not usually a guy who talks like that, but I can't compete with
Wow.
Dr. Manhattan's Rocky Mountain Betz spheres dipped in the blob. Oh my God.
It's really not. It's not edible though, because it's like
I don't know if I should apologize to the audience or like be happy about this. Or I never know how to react to this segment. I'm left so lost and troubled.
Can I tell you why I lost? Why we all lost? Because it's a sphere that you can't possibly eat, so you're just dipping it in the blob and you're just kind of licking the blob off of it.
Off of Dr. Manhattan's. Yeah. Wow. Just lick the blob off
Rocky
of
Mountain
it.
Betz spheres, baby.
I'm sorry, everybody. I'm sorry.
Not much taste anymore these days for sheep testicles.
Licking the blob off the Betz sphere. That is a perfect place for us to end part 2 of this up and down roller coaster of an alien probe saga. All right, everybody. Thanks for listening. Make sure to like and subscribe on whatever platform you're on so you can keep track of the Monster Lore Tour as we roll along. You're going to go do our side trail for this episode now. So check out our Patreon if you want to go in as deep as we go. That will be available at patreon.com/monsterloretour. You can also get early access to all our episodes and stuff in there, along with all those side trails and everything. In the meantime, we will see you here next week. Same monster time, same monster channel for more lore from the edge of nowhere. Till then, thanks again. Have a good one, listener. Monster Lore Tour Podcast.
Hodag.
Hodag.
Hodag. Hodag. Don't leave me, Hodag.
Hodag, what'd you say?
Ooh.
Okay.